I don't have a clever intro for today. I've just wanted to do this experiment since the very first episode. Also, this is what my voice sounds like today. And we're just all going to have to be okay with it. Alright? Alright. We're doing polymers. Welcome back to another episode of Atoms and Bonds. My name is Adam Rosenzweig, and this is the show where I, a real-life scientist, do a chemistry experiment with the help of an absolutely fabulous lab partner. And today, I'm joined by Izzy Uncut.
Hello, how are you, baby?
I'm so great. How are you? Thank you for being here.
I'm so happy to be here.
Yes.
I'm a little out of my element, but I'm excited to, try new things.
Awesome. Tell us a little bit about you.
My name is Izzy Uncut. I've been a drag queen for 5 years. I chose the name Izzy because I'm like, stupid girl. So I have no clue what is going on today. Being in a lab doesn't make any sense for me, but I'm excited. This is gonna be fun.
Anyway. What is your experience with like chemistry or science in general? What do you got? Where are you coming from today?
So I famously dropped out of community college, and then in high school I just did not care.
So
I was skipping class every day. I was just not doing homework. I was it was bad.
We had different experiences.
I think I did earth science 3 times, a food science, which was an elective, and then biology, and then that was it.
So we're entering some new territory today with the chemistry.
Yes.
But are you at all familiar with Nylon?
Yes. Nylon magazine was my favorite magazine growing up. Yeah, no, I'm familiar with it. I don't know how it's made.
Yes, so today we're going to be making nylon. This covers one of my favorite topics in chemistry, which is polymers, which I could really go on about forever of why I love them so much. But the short version is that everything important is polymers. There's polymers in your body. All of our fabrics that we wear on our bodies are polymers. Our cells reproduce by building polymers to pull our genetic material, which is also a polymer, apart. Everything is polymers. They just make me happy because it's where the chaos of matter and energy and chemistry and science comes into order and builds a nicer structure.
Absolutely. And if you're poly, it can get a little chaotic.
Exactly.
It's just too many people, a lot of things happening, you know what I mean? Sometimes it's a little chaotic.
We can just kind of hop right into our experiment. I have everything all laid out. But first thing we gotta do, of course, is get into our appropriate lab safety attire.
Let's do it.
So let's go do that. Alright, so we're back. Let's get into it. So, first thing we should do is introduce our reagents, and we only have 2 of them today.
1,6-hexane diamine and sodium hydroxide.
Sodium hydroxide.
In H2O.
In H2O.
Can you see it?
Can
you see it?
And then also, in our other liquid, we have sebacoyl chloride in hexanes. So we only have 2 ingredients, so we're just going to pour them on top of each other, but we're going to do it in a very delicate way. First to go in will be everything that's in the H2O vial, so if you could just uncap that and dump it right into our beaker. Dump
it right in.
Yep. So we have our water layer in. So now what I'm going to do is I'm going to take this pipette and I'm going to add our second liquid, but I don't want to just go willy-nilly pouring it on because that would cause a lot of disruption and everything would mix together and it would not be cute. What we want is 2 even, nice layers that are just sitting on top of each other because the water and the hexanes are not going to mix. So I will very gently run a pipette right down the side.
Oh, it's like making a cocktail. It's like making drinks.
Yeah.
Oh, I get it. Because they both look clear, but one is, but I can see
if you get down here,
it's crazy.
Yeah, there is a layer between the 2.
That's wild.
And that's where the magic's gonna happen. Alright, so if you, as you were, when you get down here, you can see that there's 2 layers. The bottom layer is the water, which has the hexane diamine in it, and then the top layer is the hexanes with the sebacoyl chloride in it. And so the reason that we're keeping them in 2 separate mediums is so that they only meet at the liquid interface. So when we go in with tweezers, we will experience the polymerization taking place before
the
our
one little
eyes.
area where they are touching.
Yes. If you get down here. Okay.
Oh, that's weird. Oh, that's crazy. And this will just keep going?
And it just keeps going.
Wait, that's crazy.
I know, right?
Wait, that is really weird.
And we can wrap it around.
Oh, this is fascinating.
Yeah, right? It's nylon. And they make a lot of very strong materials out of nylon. So this has like a pretty good amount of tensile strength. So we can actually take it and we can play with like how long we can make this string.
Wild.
And Imani, you get that camera off that tripod and we can go to the hall.
Oh my god, let's go. Yeah.
Oh, there we go. Yeah.
This is fascinating to me.
Yeah.
Can touch it.
Yeah, totally. The hexane diamine from the water layer and the sebacoyl chloride from the hexane layer, when the acyl chloride from the sebacoyl chloride, and then the amine from the hexane diamine, they just keep repeatedly, spontaneously interacting and reacting with one another at the interface of the two liquids. And it just keeps going and going and going. But what's cool about this is like because everything is bound together, this is technically speaking one continuous molecule.
That's wild. And it just keeps repeating.
And it just keeps repeating those repeating AB units.
And I am gonna say it. It kind of looks like cum. Right?
Yeah, but he's like, I'm a leaker.
I'm a leaker. Go off science. It's cool. I love this. This is great.
Yeah. So now that we're at the end, we can do a fun part. So how we were trying to keep our layers like separate so we would get a nice thread forming at the interface, but now like we're done for the day. So we didn't really care if, it gets all mixed up. So
what's gonna happen
if we just completely like zhuzh the hell out of it, I'm gonna use the wider end for this. It's like,
And you're just gonna get a bunch of little chunky things in there?
one giant
Oh my
chunky
god!
thing. Yeah, because everything just starts like
I thought it was gonna
slamming
be a
into each
few
other.
little ones.
Nope.
Oh,
You
that's
just get a
crazy.
big booger. Just to show the class what we've created on this day. It smells a little bit bad, that's the hexanes, but ta-da! That's what we got for today.
We love!
This is one of my favorite experiments, displaying one of my favorite concepts in all of organic chemistry, and it's that easy.
And you shared it with me!
Yeah, thank you so much for being here.
Oh my god, thank you!
Yeah. Izzy, thank you so much for joining us in the lab today. I hope you had some fun. I hope you learned a little something. Where can we find you out in the world?
You can find me all across this godforsaken town of NY City. And you can find me on Instagram, TikTok in theory, Twitter, all the shit, at Izzy Uncut. That is IZZYUNCUT.
Do you have a Venmo or a Cash App?
Venmo, at Izzy Uncut. Pay me.
Yes, we love a Venmo because in this lab we tip our queens. It's very important to support the dolls. And you can follow us here at Atoms and Bonds on our Atoms and Bonds Instagram, which is at Atoms and Bonds, ATOMSANDBONDS, or you can follow me on my personal Instagram at Adam the Chemist. Both of those profiles have a link in bio for our link tree where you can find everything else that is Atoms and Bonds related. And if you are a local NYC drag queen, king, non-binary royalty, there's also a form in there that you can fill out if you would like to be on Atoms and Bonds. Final thanks go out to director and cameraman Imani, and we will see you next time with a brand new experiment.
Amazing.
All right, bye.
Bye.